All right, we've graphed these before. Y equals negative 2x minus 3. It has a slope of negative 2, y-intercept in negative 3. So it crosses right here, negative 3, then goes up 2 over 1, up 2 over 1. So that's what we're used to graphing, okay? Now, this graph, this line, those are all solutions that make that equation true. Well, now we're going to change it. We now want to graph y is greater than or equal to negative 2x minus 3. So we're graphing an inequality. To graph it, what happens is this line, the line y equals negative 2x minus 3, is sort of a border. And all the points either on this side or on this side are solutions that will make it true. You got to figure out which side you're on. So if we take a point, let's just take the point 1, 1, and we plug it in there. Y is 1. Is that greater than or equal to negative 2 times 1 minus 3? Well, that's negative 2 minus 3. That's negative 5. Is 1 greater than or equal to negative 5? Yes. That means the points on this side are the solutions that will make it true. Every point over there, every point on this side will make it true. That's what we're looking for. Now, here's the great thing. When it's put in this form, which is the slope-intercept form, all we got to do is sort of look at the inequality. If it's greater than, let's look. If it's greater than or equal or greater than, you shade above the line. If it's less than or less than or equal or less than, you shade below it. So you see in this example, I knew right away it was greater than. I didn't even really need to plug a point in. I'm just like, hey, it's all these guys. So all I ever have to do is graph the line and then decide, am I above the line or below the line? Just imagine this being a mountain you're walking up. You're obviously walking up this side. And so you're on the upper part. The sun's up here, obviously. This is the dirt. So greater than is on the upper part that you're walking on. So let's look at another example here. Let's say they say graph y is greater than 3x minus 1. So y-intercept at negative 1, put a dot. Slope is 3, and that's positive 3. So I'm going to go up 3 over 1 to the right. So 1, 2, 3 over to the right 1. 1, 2, 3 over to the right 1. Now notice this time it says greater than. It's not greater than or equal to. In other words, the line itself that divides the two sides is not a part of the solution like it was last time. So what do we do in order on this line? If I make a solid line, then it's going to look like it includes it. So I make what we call a dashed line. And that tells people, hey, the line itself is not a part of the solution. Now, it says greater than. So we shade the upper part. Well, if you put your arm here, this is the upper part that way. So all the points on this side are solutions. So what we have is, if it's greater than or less than, you used a dashed line. If it says greater than or equal, or less than or equal, you use a solid line like that. So it's either a solid line if it includes the line as a solution, or a dashed line if it does not include it.